In this video and the series of upcoming videos, we are going to look at exploratory data analysis. Explor- Exploratory data analysis is done by the data scientist to find the underlying structure in our dataset. It also enables us to find the important variables or the columns in our dataset that we will be using in our machine learning model. Exploratory data analysis also helps us in detecting the outliers or the anomaly in our dataset. First step in exploratory data analysis is understanding the problem. We are being given a dataset of home loan by Dreaming House Finance Company. This company this company validates whether a customer is eligible for a loan or not. They want us to automate this process. When the customer is filling his online form, he or she will know whether he is eligible for home loan or not. They also want us to automate this process so that they can specifically target the customers that are eligible for home loan. So this is basically a supervised classification problem. We have to find out whether a person is eligible for a loan or not. What is supervised learning? Supervised learning is where we have input variables and output variables, and we use algorithm to find the mapping function between these inputs and output variable. What is a classification problem? Classification problem is when the output variable belongs to some category. So for example, strawberries, tomato belongs to the red fruit, and banana and mango belongs to the yellow fruits. In our case, it's binary classification. So we only have to find out whether a customer is eligible or not. So Y and N. Dataset given to us contain 13 columns. First is loan ID. Every customer contains a unique loan ID. Their gender, whether they are married or not, how many people are dependent on customer, their education, are they self-employed or not, their income, their co-applicant incomes, for example if they are living with someone, theirs income, the loan amount, what is the loan amount they want for the house, for how many days they want, the credit card history or credit history, what property area are they taking the loan for, and whether the company approved their loan or not. Now the first thing we will do is import some libraries. Libraries such as NumPy, Pandas, Matplotlib. So for NumPy, we can easily write import NumPy as np. NumPy library is used for multi-dimensional array problems. For multi-dimensional array operation, we will import Pandas SPD. Pandas is used for data loading and operations on our data, and we will import matplotlib dot pyplots. This library used for visualization. We will also import Seaborn as this library is also used for visualization. As you can see, we have imported our library. To read our train dataset, what we can do, train is equal to pd, and we have a function called as read underscore csv. We just put the path. For me it's data dash train dot csv. We will do same for a test. Test is equal to Now we will check whether our train dataset is loaded or not. Train.head. As we can see, we are given all the columns of dataset. What head function do is it will just print the first 5 rows of a dataset. As you can see, it will not print the whole dataset. Like this, if we just put train, whole dataset is right. Just want a few rows so we can know whether our dataset is imported or not. And train, what train is basically a data frame. What data frame is, as we know, in SQL we store data in tabular format, like in rows and columns, right? So basically data frame is the same thing. What data frame do is store the data in rows and column format, as we can see here. Let's display the test data. As you can see, our test data is also displayed over here. After importing the libraries and our dataset in our memory, now we will explore our dataset. The first thing we look in our dataset is how many rows and columns are available. So what we will do is we will use shape function to train. This is our data frame name. Train is our data frame name. Train.shape will print how many rows and columns are available in our dataset. There are 614 rows and 13 columns available in a training dataset. Let's look in test.shape will print as the rows and the columns in our test dataset. So 367 rows and 12 columns. So one column that missing is the loan approval. Let's look at the columns in our training data. So loan ID, gender, married, dependents, education, self-employed, applicant income, co-applicant income, loan amount terms, credit history, property area, and loan status. In our test dataset, we are not given loan status. We have to train our machine learning model on train data frame and then apply that model on a test dataset, find out the loan status. As we can see, we don't have loan status given in our test data. Let's look at the data types of our training set. So loan ID is an object, gender is an object. So what are objects? Objects are nothing but like categorical variables. Categorical variables, for example, gender is male or female, so it is a categorical variable, right? And applicant income, it is int64, it is an integer variable, right? Then loan amount is float64, it is also a number. So whatever the name or the words or alphabets, these are all the objects, those are the categorical variable. As we can see, the loan status is also a categorical variable, like y. Here we can see y is yes, so the loan status is approved. Here n means no, so we have to convert this. In a feature engineering we will do this, we will convert this to 1 and 0 for our binary classification, right? We will convert this in 1 0 also. It also converts, like look at this, this is the object object data type, right? This is a categorical variable, this is basically a text male, This is also text, this is also an object data type. Now we will check for the null value in our data set, whether uh, whether we have a null value in our data set or not. So we can use a function called as dot is null. So these all functions are available in pandas, right? What we will do is we want the sum of all the null values. Just put, as you can see, we have the null values. For example, there are 13 null values in gender column, right? There are 50 null values in our credit history. We have 14 null values in, and we can look at it. Look here, the loan amount, we have NaN value. This is basically a null value. In also also in our test data set, you can look at the credit history, null value. We have to fix this, right? We can't just go with the null values. These are the values missing. If we create a machine learning model with the missing values, it is not a right type of model, right? So we have to fix this. Now the next thing we will do is we will find the correlation between the columns of our dataset. Find the correlation between the columns of our dataset. We basically have to dot corr. So what correlation is? It will find the correlation between the columns, all the columns for dataset, and it will ignore the null values. As we can see, the loan amount has a great impact on the applicant income. So if the customer income is more, he can get more loan amount, right? It's 0.5. The correlation between these two columns is very high, 0.5. Just like that, we can also see other columns are like loan term and loan amount. I don't think this has some correlation between, like here we can see the correlation between loan amount and applicant, just like that. Then it 0.1 for this co-applicant income. Yes, the loan amount, co-applicant income. So correlation is very useful. We can find correlation function is very useful. We can find the correlation between the columns, and we will know which columns are dependent on which column, and which column has the more importance with which column, right? So if I remove this applicant income, it will have great impact on our loan amount, and if I remove this loan amount, we will have a great impact on an applicant income. Another thing we can do is we can check for the unique values. For example, train dot gender dot n unique or unique. Like, look at here, male, female, and NaN is basically not a number. Here we saw that gender has 13 null values, right? So we have female and male, and we have to remove the null values, right? We can check for unique values in many things. Like we can also check in train dot we can check for dependents, right? We can check for dependents dot as we can see whether our customer is living with someone or not. If he is living with no one, it's 0. He is living with someone, 1, family, and not NaN. We basically have to remove this null value. We will do that in data cleaning and structuring. Okay, we will remove these null values, and we will clean our data and structure our data. One more thing we can do is we can check for the n unique values. So how many unique values are present? For example, here we have 1, 3, 4. So what we can do is train dot dependents dot n unique. So there are 4, right? 0, This will n unique will not consider the null values. Okay, so 0 1 2 3 plus. We can also do this for, let's look, what we can look, what we can, for education we can see train dot education. I'm sorry, there are two. What are these unique values? Let's say they are graduate and not graduate. In our next video, we will do our data cleaning and structuring our dataset. We will remove all the null values in our dataset and replace them with the appropriate values. Thank you for watching this video.